What up, Netflix? All right. It's actually my second time filming this video, so if I go too quickly, please forgive me. The last one, after I got done, had some sort of error. Whatever. We'll do it again. You know what? First, you don't succeed. Try again, and then throw your computer out the window. No, don't ever do that. That's expensive. And I'm not willing to replace it. So, what's our question today for 9.1.3? I know it says day one, but I'm probably going to erase that because it's just a one-day thing. The essential question is, what if the quadratic isn't in standard form? What if the quadratic that should be an A, datic, isn't in standard form? And what are we talking about today? Solving more quadratic equations. And I know I have standard form written here, but I want you to write of quadratic equations. Quadratic. And for equations, I just put EQ. There we go. This standard form of the quadratic equation is y equals ax squared plus bx plus c. And usually we have it equal to 0, and we write down our a, b, and c, plug it in the quadratic formula. Everybody write formula. Actually, yours probably says formula because I'm going to correct it before I post this, but catch errors sometimes. And what do we know about it? We know that x equals, you need to write that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And if that's getting stuck in your head, you're welcome. You know what's stuck in my head this week is the Fox song. My kids rediscovered it, and it's like all I hear now is ring ding da ding da ding da ding, and I'm just like, ah! I fell asleep singing that song myself last night. That's killing me. Anyway. Now you can share my pain. So if I got that in your brain, misery loves company. All right, so what if the equation isn't in standard form? What are we going to do? Put it in standard form. Put it in standard form. Oh, thanks, Mr. Tim. What a wise man you are. What do I do if my car's broke? Fix it. Yeah, I know. Doesn't help you much, but we'll get there. Just trust me. Put it in standard form. And fill in the zeros for any missing terms. Any missing terms. So put it in standard form and fill in the 0 for any missing terms. Okay, so what does that mean? Well, let's look at it. It's different depending on the quadratic you're dealing with. So this one right here, it's already technically in standard form. I'm just missing the bx term. So if I were to rewrite this, it would be 4x squared plus 0x minus 121, right? And so then we would identify, go, okay, now we know our a is 4, our b is 0, and our c is negative 121. Awesome. And what do we do with that? We just plug it into the formula. So we have x equals negative b plus or minus the square root of b squared minus 4 times a times my c all over 2 times my a value. And what happens to these zeros? They just go away. 0 squared is just 0. And what do I have? Equals plus or minus still stays there because it's going to have a positive and negative component to it. The square root, and I would use a calculator because that's going to end up being, first of all, negative times negative is a positive. And then 4 times 4 is 16. And where's my calculator? Right here. Allergies are killing me today. Please forgive me. 16 times 121. I know it's negative 121, guys, but remember, we already evaluated that this negative times that negative is a positive, so we're ignoring it. So 16 times 121 is 1936. All over 8. And what's the square root of 1936? Well, let's find out. 44. So this is going to equal plus or minus 44 over 8, which I can do 4 into both of those, and I get 11 halves. So what does my answer end up being? X equals plus or minus 11 halves, or plus or minus 5.5. 11 divided by 2 is 5.5. Either answer is fine. Okay. So then, and that plus or minus, what does that mean? It means it's literally positive 5.5 or negative 5.5. Both will get the same answer. Because when you square them, they turn positive anyway. Let's look at this next one, B. Now, put it in standard form applies a little bit more to this one. Fill in zeros for any missing terms is what we did here. But put it in standard form. Well, it's 2x squared minus 2 minus 3x. We just need to rearrange it. 2x squared minus 3x minus 2. And then we're going to write equals 0 just to set it up. So take a minute. Go ahead and fill in your ABC. I'm going to pause it on my end. As always, when I'm about to unpause it, I'll say I'm going to pause it so that you can choose, since you're distance learning, to either pause it and finish on your own and then check what I do, or you can just let it roll and go with it. Here we go. Make sure to identify your A, B, and C. Plug it in. X equals negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. All right, I'm unpausing it. And boom, let's see what happened there. Fill it in. We get down to, by the way, when I get down to, so negative 3 squared is 9, negative 4 times 2 times negative 2 is positive 16, so 9 plus 16. Notice I just wrote this 25 above here. And that's why I don't have to necessarily rewrite this whole thing. I just know it's the square root of 25, and I know the square root of 25 is 5, so then I go straight to 3 plus 5 and 3 minus 5, right? Because we have a plus and a minus version of that. And I get the 2 or negative 1 half. Okay, let's go ahead and move on to C and do the same thing. So first, I honestly think you can factor 15 out of each of these terms, but I don't care to because I'm using the calculator anyway, and it doesn't matter. So what am I going to do if I have a number on the other side of the equal sign? Well, just add it back over. Remember, we want it equal to 0 anyway on the right side. Be careful, you cannot combine unlike terms, so just rewrite this. This is 15x squared. I wrote it underneath that, but not to combine it, but just to put it on that side of the equal sign, right? So I'm going to 15x squared minus 165x and plus 630 equals 0. Okay? So now identify your A, B, and C, solve, and we'll come back together in a few minutes. B. Root B squared is 4 times A times C all over 2 times A. Sure to use your calculator. This one will end earlier than you expect if you know what to look for. Okay, so I'm going to unpause it. Let's look and see what happened, guys. We took the root. So we figured it all down here. And again, don't be afraid of the large numbers, because what happens? I end up with the square root of 27,225 minus 37,800, which I don't even care what that answer is, because at the end of the day, if that's a bigger number, it's going to make a negative under the radical. You can't take the square root of a negative number. Therefore, no solution, or you can put not factorable, either one. And why not? Because it's not going to touch the axis. And that leads us to our last problem. What? So this one, similar situation, but instead of the c term, we have the bx term on the right side, so we're just going to subtract 60x. I'm going to put it right in between where it should go. We're going to end up with 36x squared minus 60x plus 25 equals 0. All right. So let's get our ABC term, solve it, come back together. And x equals negative b minus the square root b squared minus 4 times a times c. Helps me keep track to say it in my head and helps me memorize it too. Sure to use your calculator. All right, guys. I'm going to pause this now, because look at what happened. I tell you, don't worry about the big numbers. They should work out. And what happens, and they don't always. Sometimes it comes out with a nasty decimal, you round to the hundreds. Whatever. Doesn't matter. But we work it down here. We end up with the square root of 3,600 minus 3,600, which is the square root of 0. What's the square root of 0? It's 0. So that just goes away. I have no more plus or minus. I'm just 60 over 72. Divide 6 into both the top and the bottom, and I get 10/12ths, and then I'm going to divide 2 into the top and bottom and get 5/6. And what do we have? What does just one x value tell us? It tells us it's a double root at 560, which means it's going to look something like this. If that's the number 1, 5/6 is about right here. You go, what? What? It's going to touch right there, and move that up and not cross through. So there we go. There's 4 unique situations, math folks. Let's look on back. I do want to tell you, because I made the mistake on this one, when you look at the homework, just use a generic rectangle and diamond to solve these. And then you're going to use 28, and you're actually going to do B again at using the quadratic formula to prove that they should be the same. 29 is like we talked about a while back, where we talked about working backwards, right? You're going to start out with the intercepts and work backwards to the equation. Is there anything I need to think about in those? I've already worked them out. We'll give you a hint. Knowing the difference in squares, remember, recognizing what something looks like, you can work it backwards easier sometimes, so just keep that in mind. And then on 30 is more of a story problem, so give it a shot. All right. With that said, peace out.